Hello everyone, welcome back to our channel. Let's see the next name reaction, that is Bargellini reaction. This reaction is used to synthesize morpholinones and piperzinones by using ketones and diamine or ketones and amino alcohols. So we are going to synthesize morpholinone derivatives and piperzinone derivatives. Already we know that these type of compounds are what? Morpholines. Piperzinones means this is piperzine. We need what? Piperzinone. One indicates what? It is a ketone or not? Here we are placing a ketone. In this case, morpholine. At the morpholine we are going to attach what? C double bond. That is going to be what? Morpholinones. These kind of materials are going to be synthesized by using this particular Bargellini reaction. But here the reactants are what? Ketone with diamine or ketone with amino alcohol. So ketone is the common one, with we are going to take diamine, NH2, NH2. In this case we are using the substituted nitrogen. Amino alcohol, NH2OH. If you take diamine, the products will be piperzinones. If you take amino alcohol, the product will be morpholinones. Right? If you see the general equation, in the general equation what we are observing? NH2XH. Here X indicates either oxygen or substituted nitrogen. If X is the oxygen, we are having what? Morpholinone. If X is the substituted nitrogen, we are having what? Piperzinone derivative. If you see this particular general equation, here ketone is simple acetone. We are using sodium hydroxide in chloroform followed by DCM in 1 quaternary ammonium salt. Already we know that the representation of nitrogen is what? NH3. The salt is NH4Cl. If all the hydrogens are replaced with some R group, that is going to be quaternary ammonium salt. So R4N plus Cl minus. This is commonly called as quaternary ammonium salt. See this one, benzyl group, 3 ethyl groups. So total 4 different groups with Cl minus. This is commonly called as a phase transfer catalyst. We all know the importance of phase transfer catalyst in the organic chemistry. Right? So in the coming videos, I am going to give a brief talk on phase transfer catalysis. There we will discuss the importance of different kinds of the materials which are used as a catalyst in the organic synthesis. Right? Simply, the general equation tells us that we can synthesize the substituted morpholines or the piperzinones from ketones and what we call either diamines or amino alcohols. If you see the mechanism is very simple. In the mechanism, the first one is the what? Chloroform. Here it is the chloroform. If you observe the chloroform, the carbon is connected to what? 3 chlorine atoms are pairing with the carbon. Chlorine is more electronegative in nature or not? That's why what happens? 3 chlorines are taking electrons from the carbon or not? Thereby we are creating what? A positive charge here or not? Because of that reason what happens? The CH bond electrons move towards the carbon or not? That's why we can easily remove the hydrogen from this particular carbon. So here we are using a base or not? So in the first step what happens? The base removes proton from this particular carbon. Thereby it can generate a carbene. The reactant is what? Ketone, acetone. What will happen? This carbene ion attaches the carbonyl group of your ketone. Thereby what happens? Oxygen is going to get a negative charge. See this one, two methyl groups are there, oxygen is going to get minus charge. We have attached CCl3. This is CCl3. Okay, here what happens, the oxygen is going to attack on this particular carbon to remove the chlorine as Cl minus. Chlorine is going to be removed in the form of Cl minus. In the first step what happens, we have removed H plus or not. The H plus and Cl minus combine together to produce HCl. Okay, if you observe this particular situation, see this one, this carbon is connected to two methyl groups and one carbon, two methyl groups and one carbon, this carbon containing two chlorines, the oxygen is going to form a bond with this carbon. So here what happens, epoxide is produced or not. Already we know that epoxides are highly unstable. Why? Because the ring strain is very high in this particular case, right? So because of that reason what happens, if you have the acidic or basic medium, they are subjected to the decomposition easily. So here we are having what? The second reactant or not. In the second reactant what happens? We are having nitrogen. The nitrogen donating its lone pair of electrons to the carbon. Thereby what happens? Oxygen is going to take the minus charge. The minus charge is going to form a pi bond with this carbon. So at this carbon valency is increased or not. Thereby what happens? Cl is removed in the form of Cl minus. So we will come up with what? See this. Nitrogen donated its lone pair of electrons to form a bond with this particular carbon. So nitrogen is donating electrons means nitrogen will take positive charge or not. So in order to neutralize the positive charge, what we are doing, here we have two hydrogens or not. So one hydrogen is removed to satisfy the valency of the nitrogen, right? So simply here in this case, NH, H, H, positive charge. In this case the situation will be like this, NHH plus and the connected bond. So in order to neutralize this positive charge, what happens? The single bonding electrons move towards the nitrogen. Thereby hydrogen is removed in the form of H plus or not. So here the hydrogen will be removed in the form of H plus. So the NH2 is converted into what? NH. Now this is having one carbon connected to two methyl groups, carbon connected to two methyl groups, then CH2, then XH. Now come to the right side portion. This nitrogen is connected to this carbon or not? This carbon is containing two methyl groups. Nitrogen connected to carbon, carbon containing two methyl groups. Then followed by, see this bond. Here we have a carbon and oxygen. In between the carbon and oxygen we are creating a pi bond or not? That is C double bond O and the last Cl. Let's see. At this step what happens? Removal of hydrogen and Cl in the form of HCl to form a ring structure. In this way we can synthesize the substituted derivatives. Right? I think mechanism is very, very simple. So let us see the applications. In the first application what happens? In the general equation it is XH. Now the X is replaced with what? N and alkyl group. NH alkyl group. The simple ketone is replaced with what? Cyclohexanol. If you observe the situation, NH2 carbon carbon XH, that is converted into what? NH carbon carbon X. So this portion is same or not? In the right side portion what happens? Carbon having two methyl groups and the adjacent carbon should be having C double bond O. That you need to understand. See the situation. In the product, nitrogen, carbon, carbon, NH. Nitrogen, carbon, carbon, NH. Right side what should happen? At one carbon, two methyl groups are there. In this case what happens? It is a cyclic chain or not? That's why in place of the methyl groups we are having a cyclic chain and adjacent carbon must be having what? C double bond. So similarly The second example, say this one, NH2 carbon having substitution and CH2OH. If you have the oxygen means you will come up with what? Morpholinones. See the situation. Nitrogen, carbon, carbon, oxygen. Nitrogen, carbon, carbon, oxygen. Here what happens? We have two methyl groups and one carbon. Carbon having two methyl groups. Adjacent, what should we get? C double bond. So in this way we can easily write the product by using this particular reaction. So this is all about what? Your Bargellini reaction. Very, very important reaction. Most of the aspirants do not know about this particular reaction, but they are performing the mechanisms without knowing the reaction name. Okay, so now you people should understand the importance of this particular reaction.